market model, let us continue. And let us do a homework. Suppose D1 is equal to 8 minus 2P1 plus P2. And S1 is equal to 3 plus P1. Okay. Then D2 is equal to 12 plus 2P1 minus P2. And S2 is equal to 2 plus 3P2. Okay. Now this is the arbitrary equations, demand and supply equations, and not based on actual consumers and producers data. But anyway, let us do some homework on this. Now, suppose demand is equal to 8 minus 2P1, that means both P1 and P2 is there, the two commodities and their prices. But in supply, see, only P1. So may not be that the relevance of P2 is not here. Okay, that's why the P2 is missing, 3 plus P1. The P2, that means price of second commodity, is not relevant. Now D2 is equal to 12 plus 2P1 minus P2. Then S2, again here, the relevance of P1 is missing. May not be that P1 is more relevant to produce S2. That means, and because you see in the market, so many commodities are there, say one commodity may not be substitute or say competitive or complementary to each other. So that's why it is missing. It will not be there. So P1, the price of the first commodity, may not be so relevant to supply of in the second market. So we'll have to find out the shorthand symbols C0, C1, C2, gamma naught, gamma 1, gamma 2, and substitute in the equations for P1 estimated and P2 and solve it. Then what will be the values of D1S1 and D2S2? So as we did earlier, so this is the actual model with data. So simply we can put the values. We will have to fill up, suppose 8 minus 2P1 plus P2, okay. Then S1 is equal to 3 plus P1 plus 0 P2. We will have to complete to find out the coefficient matrix. It is 1 P1 plus 0 P2. So D2, 12 plus 2 P1 minus P2, that means 1, coefficient is 1. So S2 is equal to 2 plus 0 P1 plus 3 P2, like this. Then construct the coefficient matrix and find the determinant of that. Then use Cramer's rule. Okay. Now general equilibrium of n commodities. So if there are n number of commodities in the market, so what is the general representation of the market model? So market model is not always limited to one or two commodities. It is not for simplicity, for hand calculations we have shown here, but it is not that in the market only one or two commodities will be there. So more commodities may enter, creating more variables and equations which may be more longer and complicated. So if we add say 4 or 5 variables, there are 4 or 5 commodities and their prices, or even 10 commodities in the prices, then solution will be more complicated and longer. So under such situations, the equilibrium will be an Walrasian type of general equilibrium. So when commodities are more, n number of commodities, then equilibrium will be Walrasian type of general equilibrium. And the excess demand of each commodity is considered to be a function of the prices of all commodities. So in this case, so excess demand is D minus S is equal to 0. So this excess demand will be the function of the prices of all commodities. There will be n number of commodities with n number of prices. It can be expressed as, so QDI, I means say number of commodity, the demand of quantity demanded of ith commodities. So I may be 1 to so on up to n number of commodities. So ith demand of ith commodities is equal to P1, P2, so Pn. So similarly, supply side is P1, P2 is equal to Pn. That means these are the variables which will affect the supply of the commodity, and P1 to Pn number of prices which will affect the demand of the commodities. So equilibrium will be QDI is equal to QSI. So excess demand QDI minus QSI is equal to 0. So after substitution, so QDI QCI means this minus this is equal to 0. Also EI is equal to QDI minus QSI. So this is the excess demand. So ith commodity, demand of ith commodity minus supply of ith commodity, and EI is also influenced by prices. So the above equations can be written as like this. So excess demand, it will be a system of simultaneous equations. So excess demand of commodity 1 will be the function of first commodity, second commodity, so on up to nth number of commodities. Put this is equal to 0. Like this, there will be a system of simultaneous equations. So I is equal to 1, 2, or so on up to n. So equations will be E1, E2, so on. So there will be n equations which will determine n equilibrium prices. So since we do not know more than say 3-4 variables, so it will not be possible to calculate by hand. So we will have to take the help of the computer in program software. So there will be n equations which will determine n equilibrium prices. So equilibrium quantities can be derived from any demand or supply functions. So friends, this is all about the market model and use of the Kramer's rule in studying the market model. So thank you for watching. Please share. Thank you.